All right. So, all right, what you're looking at here is your practice guide. Now, this morning I sent an email out to all of you, everyone included. I sent out a digital practice guide. This thing has a digital copy in case you misplace this. I know sometimes it happens. You get going, you do it at home, gets lost in translation somewhere. You could, if you have access to a printer, you could reprint it. Some people don't have access to a printer, I understand. So if that happens, you can just write your work on a separate sheet of paper, and you'll just turn in that notebook paper when you turn this in. You are going to have to turn in this practice guide on Monday, January 4th. So that's the Monday we're back. Now, that's super inconvenient for people. Like, Lord, I got another day because our test is Tuesday. I need to study it. You've already had it for 2 weeks. I don't think one more day is going to hurt. But if you do need it, make a copy or take pictures of it. Then you can turn it in and you still have a copy of it. Okay? So that's what I just recommend to you. You will turn this in. Now, for those who are online, if you're unfortunate to be online during that time, you will just take it online. I'll have Zoom set up. You'll just have a piece of paper out, kind of like what you're doing right now. You'll just take it on a little piece of paper. You'll take pictures of it with your cell phone, and you'll email those directly to me. And I'll just share it just like you're seeing here.
Is hot cocoa quarantine?
What?
Yeah.
Did his sister just one?
Okay. All right. So, all right. But anyway, all right. So, as you're looking here, we're doing 5 days of review. So, that means today we're doing 3. Tomorrow we're going to do 2. Monday we'll do 3. Tuesday we'll do 2. And then Wednesday next week we're only doing 1. The reason why we're only doing 1 is that one problem will take us a while. So, I want to make sure. Yeah. So, we're going to try to do a pretty lengthy problem, and I'm going to try to get it done for you. There might be some parts you have to finish on your own, but it should be straightforward once we go through it, okay? So, but again, this practice guide will be due on Monday completed. So if you misplace it, you'll have to print off a new one using that email I sent you, or just put it on a separate sheet of paper. I will, on my website, so on the website here, I don't know if, Morgan, can you guys see can you see the marker board? Can you see like my website? Or is it just say it's paused? Is it showing you the iPad or is it showing you my screen? Hold on.
The iPad.
How about now?
I can still see the website though.
Okay, perfect. That's all I need to see.
The website.
Yeah, that's all I need to hear. Okay, so, all right, so we have the website open. So if you're on mrward.org or ghvmath.com or whatever address you want to call it, right? So, once you're on the website, okay, you're on the main site, you can scroll down and kind of see the notes at the bottom, or if you just stay at the top of my website and you click on the Daily Lessons tab at the top up here, right, and you click on that and you go down to Calculus, I'll have all the videos, obviously all the videos are there for the whole year. I'll have the videos for our review for our semester practice. It'll be in a new category right here. It'll say, you know, part 1, part 2, part 3, part 4, and you can click on whatever video you need to watch. Obviously today is part 1, tomorrow's part 2. You get the idea.
Did you always do this every year?
Every year.
Oh,
So they're all up there still.
I don't
So,
remember that.
yep. And so, now, the only videos I don't have on this website are the ones we did during homecoming week. That was the only videos I don't have posted. Because that week was shortened anyways, we didn't do much. So, yeah, we didn't do much during that week. So, what?
You're recording yourself over break?
No, I don't. So I'll just have the videos we do today, all those posted so you can go back and watch. Okay? But those will be on the website, so just be kind of well aware of that. Some people just need to see that. Okay, so now, let's discuss what we're going to do here. Obviously, we're doing 3 questions today. If you have questions about this stuff, that's why I'm only assigning 3 problems today, so that you know how to do them. So they're not being overwhelmed. We can process them a little bit. You can ask questions about that specific type of problem. So it's manageable. The test we take, the semester test, is a 1-day, 1 class period test. 1 day, 1 class period. You cannot finish it after school. The reason why, I leave immediately after this class is over tomorrow, or on Tuesday. Like on Tuesday, I leave. In fact, I leave pretty close near the middle of this class.
Wait, why
So,
are you on vacation?
4K.
because of basketball, JV has we leave at like 2:25.
What?
So the
You're gonna be right in the middle of this class.
yeah, so it's kind of in the middle. It could be near the end. I don't have the official time when we're leaving. It's at Humboldt that day.
Oh,
So apologies for that. If once I get the confirmation of what time JV leaves, maybe for like Morgan or Jake, if you guys are online at that time, who knows if I'm not, but if you guys are online at that time, I might have you have to take it Wednesday online with me, just because I won't be here to actually click through the slides. They should be. So, all right, but again, so just be aware of that. It has to be done in one class period, and so just be well aware. All right, so let's get going. I want to get through these so you have a little bit of time at the end of class. We have about 35 minutes here to do 3 problems, and they're not even difficult today.
Let's just
So,
go right through the boards.
we're going to cruise unless you have questions. All right, so now let me zoom in here.
That takes 3 or 4 class periods by itself.
Okay, all right, that'll work. Okay, so first one here. We have to write the equations for the parallel lines and perpendicular lines. And I even give you a hint. It says, parallel lines have equal slope. Perpendicular lines have the negative reciprocal for slope. So I give you the hints here. Now, what we have to do is we have to be parallel and perpendicular to this line right here. And we have to pass through this point. So basically the sole equation for this, pretty much this whole test that you need to know, that you need to have memorized, is the point slope version. So that is this form, and this is pretty much the only thing you have to have memorized. This is the one formula that I'm going to refer to. That's point slope form. Now, I'm going to have to do this twice, because if you didn't read the instructions on this problem, I have to find the equations for parallel and the equation for perpendicular. So there's two answers here. Let's do the parallel first. So for parallel, I need to find my slope for the line that they provided me. Now, the line that they gave me was not in the right order. If I rearrange this, how do I get it to look like y equals mx plus b? What do I need to move?
The x
The x. So if I move the 4x over, what happens?
becomes negative.
Becomes negative 4x. So hopefully that makes sense to you. Now, why I'm doing that is because now I can read off what the slope is for that equation. For a linear equation, the slope is the number in front of the x. So what is my slope going to be for my parallel?
Oh, negative 4.
Negative 4. Because their slope was negative 4. My slope for parallel has got to be the same exact number. So that's the number I'm going to use. Now the coordinate I'm going to pass through is the coordinate they gave me, the 1, 5. I'm going to plug these numbers into that equation that I have printed right here. So that is the y equals, or the y minus y1 equals m times x minus x1. I'm going to plug those numbers in. So here's what we have. Y minus the 5, the negative 4 is my m, and x minus the 1, and that's it. This is what I'm looking for parallel. Does that make sense now?
Yes.
It's a parallel line, it's got the same slope, and it's going to pass through 1, 5. And again, how I knew where to plug those in, this is my x and this is my y. They're in alphabetical order, so I know which one to plug where. And they just go in the x1 and y1 spot. The little ones denote where you plug them in. And you'll always subtract whatever those numbers are. So even if it's negative, you'll subtract a negative, which makes it positive. Questions with parallel?
No.
Okay, now, the second part we have to do here. The second part, we have to do perpendicular. Now I'm going to take a screenshot here just so we can do the perpendicular. Okay. Let's do the perpendicular piece now for this one, but I want to make sure everyone's got this written down. If you have any questions, let me know right now.
No.
No questions. Not on this one.
On this one,
No
anyone?
further questions, Your Honor.
Could I put it in the y equals mx?
Yes, you could rearrange if you want to. You don't. It doesn't matter. This is probably easiest to plug it in and done. Okay? All right, so now, if we go to perpendicular, so I'm going to go to a new color here.
Purple.
Yeah, let's go to that purple color. All right, so same exact thing. All right, now we're going to go to perpendicular.
That's pink.
Purple for perpendicular.
Perpendicular.
That pink.
You know what I meant.
Work hard. That pink.
All right.
English.
Yeah, I don't think I have a purple, but the pink will work.
It was up there.
It's still black hard.
That one.
That?
It's like indigo, but it's more purple.
That's like a navy.
That's pink.
All right, anyway. All right, so perpendicular here. My slope for perpendicular, it has to be the negative reciprocal. That means whatever my number was, I'm gonna flip it over, so it's gonna be 1/4 now, because before it was 4/1,
Change the sign.
and then we have to change the sign, so it's gonna end up being positive. It is the opposite reciprocal. So it's the opposite sign of my slope, and it will be the reciprocal. We flip the slope
if it
over.
was -6, it'd be positive 1/6.
1/6. And if it was like 2/3, it flips over and it's 3/2, 3 over 2, and it's negative.
Okay.
Opposite reciprocal. And then my coordinate I'm still passing through is 1, 5. So if I plug this in, here's what we have. Y minus the 5. The positive 1/4 now, instead of -4, right, it's the opposite reciprocal. And x minus the 1. And that's my formula for perpendicular.
It says graphical equation.
And then graph, I have the graph in the next part here. Yeah, we're going to graph.
If there's like -4/1, would it just be +4?
Yeah, you flip it, yep.
So, but if the parallel slope were +4, then it would be -1/4?
Yes, absolutely right. Okay, are we ready to graph this thing?
C.
Okay, so we're gonna go graph this. I'm gonna add the graph to the next slide here. So, all right. Wish I had a graph.
There it is.
Let's see, where's my graph? Yeah, I want just a blank graph. Do I have?
Inserts.
God, this is giving me a headache.
Yeah, sorry. All right.
Right
All right. We'll just have to. I'll just pick one of these and I'll just make it really big.
It's like a roller coaster.
Yeah, it's giving me a.
Yeah, sorry.
Right.
I'll just pick this one. All right.
Good.
There we go.
Beautiful.
There. We'll just cheat the system a little bit. All right. Okay. So, all right. So we're gonna graph this thing. So the two equations I had earlier, y minus 5, and that was what, -4 and x minus 1, right?
Yeah.
And then that was parallel. Parallel. And then my perpendicular line was y minus 5 and the 1/4 x minus 1, right? And so those are my two lines, and I'm going to go graph these. So to graph this, I know that I have to pass through 1, 5. 1 over 1, 2, 3, 4, 5. So I know I'm going to hit 1, 5. So duh, I don't even have to think about it. For parallel, what does that slope of -4 mean?
Goes down
over 1.
Yeah, down 4 over 1, right? So the negative just means it drops and it runs to the right. Drop 4, 1, 2, 3, 4, run 1 to the right. Drop 4, 1, 2, 3, 4, run 1 to the right. And you can keep doing that over and over and over. You don't need to. All right, there's the line that's supposed to be parallel to my other one. What was the equation for the original line, by the way?
Y plus 4x equals 7.
Okay.
Is that the...
It was, yeah, y minus 4x plus 7. Okay, so that one started at,
That's correct because he hasn't.
Oh, yeah.
yeah. So plus 7, 1, 2, 3, 4, 5, 6, 7, and it was going down for 1, 2, 3, 4 over 1. So you can see that, yeah, they are parallel. They're just really close together. So the yellow one was the original. You didn't have to do that one. I didn't care about that one. I just wanted to see you graph the parallel and graph the perpendicular. So I'm just showing you why it's parallel. All right, but perpendicular now, the only difference here on the perpendicular, we're still going to hit 1, 5. My slope now is, what, 1/4? That's the only difference. So what does that mean for 1/4?
Oh, we're up 1 over 4.
Up 1 over 4. It's rise 1, run 4. And we're still going from this same dot. We're still going through 1, 5.
How'd you get the yellow one?
That was the original one that they gave us.
Oh.
I just threw that in there just so you could see why it was parallel.
Okay.
That you didn't need to draw it. That was just the original one that was on the other page.
Yeah.
So I'm going up 1 over 4, 1, 2, 3, 4. And so this is that perpendicular one. And it makes sense. Perpendicular means intersecting. It's going to hit at 90 degrees. So, questions?
Nope.
All right, I'm going to take a screenshot of that just so you guys can see it.
Beautiful.
And again, where I got all of these numbers from, oh, maybe I should zoom out. I didn't realize I was so zoomed in. Sorry, guys. I didn't realize I was so zoomed in on that. All right, but again, where I got all these numbers from, it was from the other slides, right? If I go back to the slide that we just did previously, this is where I got all those numbers from. It's from here. So that's why we did those. Okay. I'll go back to the graph. Sorry. Let me know when you guys are good. So especially the ones online, let me know when you guys are good. Good. Good thumbs up.
practice this morning.
It was good. Actually, I didn't mind it. So we got a lot accomplished for at least the JV unit anyway. I don't know how the varsity did.
Oh,
Yeah.
you were nice to JV unit early?
Just like 2 minutes. We already shot our free throws. They were just getting done with their drill, so I'm like, just go.
I don't want you to do
They were fine.
Shoo, shoo.
They already went through all their stuff. They already shot their free throws.
Next one.
Okay, let's move on.
that. Did you forget how to coach? You've been gone for so long.
It was kind of weird. All right, I didn't know any of the plays. He put in so many new plays, I didn't even know them all. Yeah, I know, and I wasn't here for any of them. All right, so,
Please?
yeah, sorry, Morgan.
Oh,
Oh,
God.
she's gonna be real lost.
Well,
Yeah.
she's got a Christmas break.
Yeah, she heard that. We'll get you filled in, Morgan. All right.
You're gonna be lost.
Yeah, at least you'll be back on the days we just have to practice. All right. So, solving for x using logarithms. So, this is one where you have to either do a log to both sides or a natural log to both sides. It's really easy. You're going to do the same rule to both problems. This one requires the calculator. That's why I said you're going to want one. I'm going to show you how to type the stuff in if you need it. If you don't, I won't show it because some of you are pretty good with this. I will want you to give me the exact answer and then also to give me like the decimal what the calculator says. So that way you have to show me that you can use the precision tools of mathematics. So you have to show me that you can use this. Yeah, that's literally a standard I have to test on you guys.
This is a precision mathematics.
Seriously, that is literally what the standard says. Whoever typed those, you got paid way too much. All right, so
Like my word.
all right, let's.
I got paid per word.
So yeah, pretty much. All right. So let's go through these. So on this first problem, I'm just gonna take the normal logarithm. Now, why I'm taking a log of both sides is because this was a 17 and not like a natural number e. And you're gonna take the log of both sides. That is a property of equality. You're allowed to do that. Now, when you take a log of both sides, and again, this was from our first unit, if you remember back to this, we had to drop the x out front. Yeah, this was back in August. We had to drop we have to drop the x out front because that's a power of a logarithm that you can drop exponents down. And then the last step is you divide the log of 17 over. Log of 17 is just a digit, right? You type it in your calculator, it gives you a crazy decimal. And so you're going to divide this both sides by the log of 17. Now you don't need to show that. I'm just going to type it over there on the other side. And so your actual answer for x turns out to be x is equal to log of 2 divided by log of 17. It happens
Which
weird.
is 0.24465.
Okay, yeah. Now, when you type this in a calculator, you want to type the log of 2, close that parenthesis, hit the division key or the divided key, then type in log of 17 and close that parenthesis, and it should give you a crazy decimal. I want 4 decimal places to be accurate. Now, I'm going to show you how to type this in just so you guys can see it on mine. If you have your own calculator and you want to see it on yours, that's fine. I'm just going to show you here real quick. I think everyone at home can see this as well. All right.
Oh my god, the fingers.
Or this
Oh my god.
Oh, those
What?
COVID fingers.
Spreading
Or you
it.
get a new calculator,
All right.
new iPad?
What?
You get a new iPad?
Yeah. Got an iPad Pro.
Okay.
Was that during quarantine?
Yeah. So, all right.
Never put Ward in quarantine. He'll buy too much.
Oh, I bought a ton of stuff. All right.
Sounds like
Can you
March.
I bought too much stuff. All right. So, so to type this in, log of 2. So there's a log button. It's right here, log. And then you're going to type in 2, close the parenthesis, hit the division button. That's the little divided key. You type in log of 17
Those hairy knuckles.
and close the parenthesis. Quit it. All right. And when you hit it, it's 0.22465.
24465.
Yeah. So I'm gonna write that down again. Just that log button's right there. So
He's like scared now. Way to go, Travis.
He's a genius.
okay.
He could be a hand
All right.
model too, though.
No, definitely not. Not with these
Just
hands.
for a calculator.
24465. All right. And that's the number I want to see.
Decimal spots, though.
Yeah, 4. So if you want to go 2447, that's great.
He's an overachiever.
All right. Questions on number 2.
No, let's
Okay.
do the next one so we're done.
Last one. This is our last problem of the day. No jokes. I only said I only do 3 today. Okay. So. Okay. So what we have to do on this number 3 is we have to get rid of the 5 first. Now, why I have to get rid of the 5? We just need to get the item that has the exponent on it by itself. So we have to divide this 5 over first because I'm technically dividing both sides by 5. That way the exponent item is by itself, right? That's what I need to do. So 7 divided by 5 on a calculator is 1.4. So I'm gonna write that number down real quick. Okay.
My brain's too slow for this.
I know, sorry.
I know.
Okay. Now, we're gonna have to take the natural log of this one, or you can take the log. It works either way. I'm gonna do the natural log. I'll show you why. Why I'm gonna do the natural log on this problem is because this problem has an e. So if you do the natural log, not the normal log, it will simplify this problem a lot faster for us. So watch how this works. So if I take the natural log of this, that's the little ln, not the log, but the ln button. That's natural log of 1.4. On the other side, I take the same thing, the natural log of e to the 0.2x. What will happen, we're going to follow the same rules as the last problem, right? You're going to drop the little exponent out front. So this little exponent right here will drop out front because that's how the natural logs work, right? The exponents can drop out front. So this will end up being 0.2x times the natural log of e and natural log of 1.4 on the other side. All right, whatever your thing is, this is how it kind of works. Oh yeah, let me move that up, sorry. Oh, hey, sorry. And now, the thing is, why did natural log and not just the log like the last problem? Is because this item back here, the natural log of e, is just 1. Because the ln means you're taking the log of base e to the e. Which is 1. It's what power you put on an e to make e, because this is what this stands for. Log of base e to e. You're figuring out what power you put on this to make e. Well, you put a 1 on it to make e, because it's the same number. That's what the ln stands for. It's a shorthand for the log of the natural number. So when we do that, this basically cancels out, so I don't need to worry about that. And so all I need to do to solve for x is divide this 0.2 over, and then I'm done. So it's going to end up being x equals, and on the other side, the natural log of 1.4, and we're going to divide everything by 0.2. And that's it. That's how you do it. Logarithms are really easy. And if you don't know what a logarithm is used for, it's used to figure out what powers you can put into numbers that give you a certain value. Like on this problem, I'm trying to figure out what the growth is, like that x, that would produce 7 out of this thing. So it's growing to the number 7. I'm trying to figure out what power, how many years it would take to grow to 7 if the population started at 5 of whatever this item is. Maybe it's bacteria or maybe it's population, who knows. So when you do this, natural log of 1.4.
You're not going to show us?
Oh, yeah. No, sorry. Didn't even think about it. All right. So, all right. Okay, so natural log. So that's the little ln button.
We can't see the screen, bro.
There you go. Oh.
Oh my gosh, it's so hard. It's like inverted. All right, so natural log. So this little ln button. And then I'm going to type in the 1.4. Close the parenthesis off. And then I'm going to divide by the 0.2. Or 0.2.
Is it fine if I just figured that out before and then divided over ln?
Yeah, that's fine.
Okay.
And so I get 1.68. Is that the same number you got?
Yep.
I got 1.6825.
Good.
4.
Well, when I divided it.
Yeah,
Well, I rounded it all.
Okay. All right, but there you go. 1.68. 2.3. Or 2.4 if you round.
We're done for the day.
And we're done.
Ward, I have a really
We can't
important
play
question
chess
for you.
today. Very just-
Hold on. Let me write this down, then we're going to be done. All right. This ends up being 1.6824. 24. There we go. There you go, guys.
Or don't figure out who stole your chess pieces.
No. Supposedly, what the last class said, period 7, said it was one of the secretaries came in, which I don't understand that. So they said it was an older lady that came in and borrowed it during period 7. So I don't know. I went and talked to the main office to Jan and Beth, and they didn't know anything about it. So I'm gonna go talk to maybe Paula had to borrow it for some reason, or what I'm thinking in my head is it was possibly it could have been, and she's not older. Could have been Mrs. Cumsher. Maybe she needed it for tag. So, and she just saw it was a sub that day and she's gonna borrow it. So I'm gonna go talk to
Terry
them.
Klager.
So.
Wait, what day was
So.
that?
It was yes, it was the first day that I was gone and I didn't know.
Yeah, it was like right away.
Maybe they sold them.